For rate of change, just remember your chain rule. So what you want is, let's say they ask you to find dVdt, right? You just do this first. This is a chain rule. Just put the blank. Okay, then you fill in the blank later. Understand? So for example, if you're finding drdt, dadt, say similarly dadt, you just put it like that. Whatever they want you to find, you just use chain rule. Chain rule is king. So you just be where you use this even at H2 math level. I keep using this. It works always one. You won't get. So we slowly understand what's going on. A spherical ball is completely filled with air. Air is then being released at constant rate. Okay, this one meaning to say air. You do not. This air is being released. You see this cm cube. Okay, so the air is coming out. dVdt is negative k cm cube per second. Okay, given that the rate of change of radius of a ball is this, write this down also. Just write all the things that you have. So this one here, what we'll have is drdt minus 1.5 cm per second. The radius for r equals to 4. Okay, find the value of k, leaving your answer in I. So this case here, okay, you start with 1. Either one will do. You can start with dVdt, right? Show that k ma. dVdt is equals to dv something dt like that. Okay. Then what you need to do is what? This one I want to put dr, because you already dr this dr. Right? So that's about it. Now you already have dr here. Now what does this tell you? This tells you that this one is already fixed because you already have this, right? This one prompts you to find v in terms of r, which you know lah. Then differentiate, right? If this is dv dt, obviously if this is dvdr, you need to find v in terms of r. That's which we know. We know how to. If you do not know how to find v in terms of r, sometimes if say dvda is equals to dadt, right? Okay, let's say this is dvdt. You're given dadt. Then this one you do another chain rule. Just use chain rule, guys. Chain rule is your friend. You do another chain rule, then you just fill this as r and r. Then so you keep using chain rule until you get the things that you want. So this case v in terms of r, I'm just gonna put v. Volume in terms of the radius is 4/3 pi r cube. Then you dvdr lah. It's easy game already from here. dvdr is 4 pi r square. This would be 4 pi r square minus 1.5. Then dvdt is negative k. Then subsequent one, you just put the rate of change of surface area. So B, you want to find dadt, just use chain rule. No need to ask so much on, just use chain rule first. Right, first thing is to understand that this is a fixed rate, constant rate. Constant rate means it doesn't change, okay? So the r equals to 4, the radius r equals to 4 only happens for case A, part A, okay? Very likely for part B, there's a new r, understand? So your orientation super important. Now, if you know that this one is you need to put this as dr, you are right, you're on the right track. So you probably will get 1-2 marks from here, okay? So dr dt, not an issue. We are told that given that dr dt is what? Shucks. A third of dv. dr dt, change of is 1/3 of, okay, so the volume dv dt is negative, so this is negative 96 pi. Agree? dv dt is negative. So that will be no longer 4 already. The no, because dv dt is constant. So because it's a constant rate, right? This rate is constant, right? Meaning for A and B, it will be the same rate, but dr dt will be different rate. Constant rate means now is the same, tomorrow is the same, 1 million years ago is the same. So the rate which is constant, right, applies to all cases. So imagine you have a sphere. The sphere is like decreasing in radius, right? Right. The radius, the change of radius would have a different rate. So you'll be slowing down or going up. But the balloon, right? The volume coming out from the balloon, right, is actually constant rate. Meaning it fart at the same rate. The air coming out is the same. You put a paper down there, when the air come out, it will just flap at the same time because it's the same volume coming out. That's what they're trying to say. So the rate of the air coming out is held constant. Okay. You know that you have your dr/dt fixed. This prompts you to find what? Find A in terms of guys, like I say, you just use chain rule, forever win one. So A is equals to pi r 4 pi r square surface area of sphere. dr will just be, there you go. So this case here, we get wow. Okay. You agree we need to find the r? The r is the one which changes. So dr dt, just now we know dr dt is dr dt is negative third pi. We need to find the r. Okay, this one take note. We need to find the r here. We don't have the r because we can't find the dA dt if we don't have. So what we need to do is we need to use this one here. This equation here to find the r. Okay. So this one careful. Maybe not this the equation, because this one is changes, this one. Follow me very carefully. So you know that dv dt is equals to dv dr times dr dt. So you put this one over inside here. This one is a new boundary. Then this dv dr is as per usual. Then this k we already found. Okay. So this time here, what we get is negative k. So it's negative 96 pi. dv dr is 4 pi r square times negative 32 pi. So you have dv dt, right? Am I right? dv dt is what? dv dt is minus negative 6 pi lah. Alright. So in other words, r would, so in order for you to relate both of them, you put dv dt is equals to dv something times dt. So you use dr here and dr here. So once you establish that, you know that v is you need to use this expression here. This is 96 pi. dv dr will be 4 pi r square. Then dr dt is negative 32 pi. This is it. So this is your r. There's a boundary condition. So essentially, dA dt minus decreasing rate. Working calculator, this will be